All of you are welcome to the chemistry part, and that is also related with the engineering chemistry. The technologies available all over the world, and what are those responsible, the materials itself. So today we discuss about the polymers, in which the most one, the polymer itself is the nylon, is also mostly related with the engineering and technology, as well as different fibers, whatever. So nylons are the condensation product of the carboxylic group and ammonia and NH2 ammonia amine group. So carboxylic group and amine group form the amides. That is the carbamide. So let's we have to consider the polymers, and then nylon polymers are the condensation of carboxylic group with amino group. So what is the carboxylic group? Here we can say that carboxylic group is carbon double bond oxygen, and then hydroxy group. So that is the uh, carboxylic group concerned with the organic compound, organic acid, whatever that. So carboxylic group, here we can take the dicarboxylic acids. All of you are well known about the oxalic acid. This is two carbon atom dicarboxylic acid. Oxalic acid, whatever that, C double bond O, then hydroxy group, carboxylic, and another carbon double bond oxygen, then hydroxy. So that is the oxalic acid. Here, dicarboxylic acids are of so many types. Monocarboxylic acid, that is the very simple, and that one is uh, the acetic acid. For example, CH3COOH, carboxylic acid. Here, one carbon carboxylic acid is the formic acid. So, formic acid and acetic acid, two carbon atom, three carbon atom, propionic acid. Similarly, if we have to follow the two carboxylic group in a molecule, the simple two carbon group dicarboxylic acid, that is the oxalic acid. So this is the two carbon atom dicarboxylic acid. Here, what we have to add amine group, and this is also very important in our life. Why? Because the proteins which we are using in our life, and that's available all over us, around us, and that is one of the important constituent of our body, and that ingredients, the proteins. So what are the proteins? Anyone? The proteins are also the polyamides. So what about the meaning of the polyamide? Amide group. So nylons are also the polyamide. So all of you can compare with the proteins with the polyamide, and that is the nylons also. So these are the very specific polymers nylon. Whatever there may be certain nylons are very rigid, even that can be compared with the stones. Stone-like properties are also there in certain nylons. Even if suppose we have the whatever the vehicles, and here the ball bearings. So ball bearing, the wheel is revolved over the with the help of the ball bearing. So certainly ball bearing itself, that is made up of the metals or alloys. But here the substituted by the nylons. It is easily, but that we can compare whatever the chemistry, and their materials are the mother of any of the technology. Whatever our body is also the mother of our body is the chemicals, natural chemicals, the proteins. Proteins, all of you are well known about this. Deoxyribonucleic acid, RNA, all are the examples of the protein. And those have also the concerned proteins are the polypeptide, and peptide itself is the amide bond, and amide bond is the it, nylons. So we have the proteins, fibrous protein. We have the muscles, and that is the muscles polyamides. So how proteins are there? All of you are well known about that. The amino acids, an amino acid, one amino acid combined with the another amino acids, then the formation of the amido bond. So that is the same thing in the nylon. So nylons, whatever those are the synthetic, those are prepared in the laboratory. And why these nylons are prepared? Because we have the certain requirements. What are those particular requirements? Certain in case of the uh, in certain functional values. I have discussed about the substitute of the ball bearing with the nylon polymer. Is it possible? But possible. In the high value added technologies, polymers have the great role. Polymers have changed the whole world, and one of the most polymer is the nylons. So nylons are the polyamides. Amide, amido bond, and this amido bond is formed by the combination of two functional group in organic compounds. The one functional carboxylic acid, another is the amine. So that is also present in the nature. All of you know about that. The amino acids, number of amino acids are there, where the ammonia group attached to the carbon, the carboxylic group attached to the carbon. Simple, one carbon, ammonia is linked, another side carboxylic group is there. So amino acids, very specific property, and because of that specific property, we are here. The proteins. Finally, muscles. Our muscles are related with the polypeptide, related with the polyamides in the chemistry, in the chemical sense. The basics is the polyamide. So nylons are also the polyamide. Whatever that, the condensation, we have the polymerization, condensation polymers are there. We have already discussed the polymers in detail in the introduction of the polymer, where the polymerization process I have already discussed, the different types of polymers, the different polymerization technique, that particular polymerization, whatever those, the addition, one type polymer, the copolymer, another type, and third one is the condensation, condensed polymer. So here the nylons are formed by combination of two functional group, and very little molecule is eliminated. So that is the, what is that? So that particular is the condensation of two molecules combined with each other and form a new bond. That is also in the protein case. Around 20 amino acids, and they form a number of proteins in animals and plants, whatever the whale, whatever human being. Very, the aquatic animal, very heavy animals are there, and there is the plant. Certainly proteins are the responsible. In case of the plants, different proteins, and proteins, whatever we have the body, and that is the most important body structure is, that is related with the polypeptide, that is related with the polyamide. The same thing, polyamide, polypeptide, and that is from the amino acids, and that is the proteins, globular protein, very flexible protein inside our body, whatever the movement. And this, the movement of my finger is because of the polypeptide, because of the proteins. So that is the strength. So strengthful. So nylons are also strength. Even uh, here, certain nylon polymers are also the substitute of anti-ballistic material. So anti-ballistic polymers that can be obtained with the certainly the nylons, those are also the polyamides. But here, in that case of the anti-ballistic polymers, bulletproof, bulletproof plastic, bulletproof polymer, those are the polyaramide. I have substituted one word is here, polyamides and polyaramides, where benzene ring is there instead of the whatever the aliphatic carbon atom. So great value of the nylons, and it is most important concern for various technologies. However, whatever the different technologies I have mentioned, that nylons have also the properties similar to the stone. So where stonework is going on, the nylon is the substitute. Here, the many different machinery parts, those can be substituted with the help of the nylon. But this is the magic, this is the miracle of the chemistry, miracle of the compounds, miracle of the research of the chemicals. So that can leave, that can enhance our whole facilities, our whole uh, facilitation with the new technologies which are generated, whatever we are going towards the Mars, towards the space. So that is because of the certain polymers. So nylon itself is one of the fundamental polymer in and fundamental class of the polymer, and that is because of so here we can I change the nylon polymers. Whatever the meaning of the polymers, all of you are, I think, well known, and this is the polymers itself. I have discussed here earlier. Here number of polymers, whatever the polyethylene, polypropylene, polybutylene, number of polymers, and including that, the nylon is also one of the polymer. And nylons are the polymer of carboxylic acid and amine group. So it's we have different application basis. The polymers are of the usage, either plastic and the rubbers, elastomers. Rubbers are also called elastomers. So plastic and rubber based on the uses. Polymers are of two types. Whatever heating behavior uh, of polymers, thermoplastic, thermoset. Thermoplastic, the word heat, then in the molded form. When heat is given, that is the thermoplastic. And when thermoset, when heat is given to the plastic, then this become a set, so that cannot mold it itself when there is the plastic one. So thermoset and thermoplastic based on their the heating behavior. So here something natural also, whatever many units, that is the polymer, high molecular weight compounds, that is the miracle of the chemicals. Then natural, I have mentioned number of natural polymers. So whatever the proteins, whatever the silk, silk is also one of the example of polymer. The cotton was the rui, and silk, whatever the silk. Then wool is also obtained from the various animals. So those are the natural polymers. Then synthetic, which are made in the laboratory. So that concern is the how we can design the specific properties in that particular polymer. If we have the paint, whatever we can say, the different paints are available, weather paint. So there are certain polymers are added by which that particular paint protect us, protect our houses, protect our buildings. So they are the very specific paints, and which we can get. So paints are the coating material, but in that is also the role of high value added polymers are there. So natural and synthetic, whatever the thermoplastic I have mentioned, then thermosets we have the polyamides. This is one of the class of thermocell. Polyamides, and polyamides are the proteins, polyamides are the polypeptides, polyamides are the bulletproof polymer, polyamides are the nylon, and the meaning of polyamide we have discussed, I have earlier discussed, that is the combination. Is that the combination of carboxylic group with amino group polypeptide. One more thing is the polyesters. So if suppose we have to talk about our the clothes, that is the synthetic fiber, that is polyesters. Ester group is formed. So the basic of the organic chemistry, carboxylic group combined with the alcoholic group. So polyesters are formed. Very great value of the polyesters, whatever the synthetic fibers in the used in the clothes, specific polyesters are used. So we have to see the polyester and here the nylons. So both can be correlated with the two functional group and one functional group in polyester and polyamide is the same. And which one is the same? Carboxylic group. So carboxylic acid combined with the amine, carboxylic acid combined with the hydroxy alcoholic group. So that's the very miracles, whatever the our sustainability, our facility is provided with the chemistry, with the chemicals, and those chemicals, what are the polymers, and polymers are used in different technologies. Whatever if, I have this wire, that is also the polymer. The specs, the here, the sheet, whatever that is the polymer. So great value. Even if suppose we have to concern about the button in the collar, that is also the polymer. So whatever this, all those are concerned with the polymers and a great value. And also whatever then we have to see and polyamides, the versatile polymer, whatever I have discussed, very specific polyamides are the considered the first engineering thermoplastic, and polyamide is one of the many heterogeneous thermoplastic which has atoms other than carbon in the chain, carbon and nitrogen. That is the amide. Amido bond, carbon double bond oxygen, and then nitrogen and H2, CONH2. So here the polyamides invented in 1928, about 100 years or less, and DuPont, whatever the very great industry DuPont, in search of a super polyester fiber with molecular weight greater than the 10,000. So first commercial nylon was in the 1938, before no existence of the polyamides. So polyamides, what are the nylon, was created when a condensation reaction occurred. Whatever I have discussed, the condensation polymers, the amino acids, and then dibasic acids and diamines are used. So nylons described by the number of systems which indicates here. Amino acids polymers are also, that is whatever that can be in case of the. So here I have already discussed the polyamide, a versatile polymer, condensation polymerization. This process is there. In case of the certain other nylon polymers, there may be the copolymerization. Here what we can say, for example, omega amino uh, hexanoic acid. So here the one of the molecule where that is like a amino acid. So amino acids, why amino acid? Amino group one side or carboxylic group other side. So nylon 6 is obtained by the self condensation, and that is the. So here also NH2 group and carboxyl group. So whatever we get the condensation and we small molecule is liberated, or it condenses from the reaction A plus B, and small molecule is the water, and we get. So here for more of the polymer nylons, we can use also the co-polymerization process. So basically is condensation polymerization. We have seen hexane, 6 carbon atom, dicarboxylic acid, then 6 carbon atom, diamine, whatever those, hexamethylene diamine, and then hexane dioic acid. So here, 2 carboxylic acid, those combined one carboxylic acid of one molecule and condensed with the another amine group uh, organic molecule. So there is the condensation, and then we get the condensation product, and definitely that is the miracle in the laboratory. So this was invented polyamides, whatever at that moment the polyester having the so more molecular weight polymers, and in 1938 the existence of nylon occurs as a synthetic polymers. However, the similar compounds in the nature are also available. What are those? Different muscles, fibrous proteins. Those are also the polymer. But in the laboratory, nylon was seen in 1938. So since that, a great changes in the nylon polymers. So whatever this can. Now we have to come the polyamides. This is hexamethylene diamine. You can see the picture of the polymer of the nylon 6.6 polymer amide. What is that? A nylon polymer. And what about this hexamethylene diamine? So hexamethylene diamine, that is the specific. So we can say here the 6 carbon atom carboxylic acid. You can here the in the picture. This is the condensation of two molecule. One molecule is the 6 carbon atom, and where uh, at the end of the 6 carbon atom, the group is the carboxylic group. And in another case, two amine groups are there. So they form a condensation product. How condensation occurs? Because of the carboxylic group. So carboxylic having groups have also the combined group of two functional groups. What is that? The carbon double bond oxygen, one group. And then this combined with the hydroxy group. So carbon double bond oxygen and then hydroxy group. So that is the carboxylic group. So carboxylic group combined with the amine. Amine itself, that is the NH2 group. So that is the similar to the amino acids of nature, amino acids of the different proteins. If we have to see the dry fruits, protein specific proteins are available, specific proteins, and that are characterized, and that those are helpful to our body. But whatever, if suppose we have to talk about the different pulses, so specific proteins are available in the pulses. So here also we get the specific like a protein, because proteins are also polyamide, and this compound, this polymer is also the polyamide. This polymer is called nylon 6 double dot 6, because 6 molecule from one side, 6 carbon molecule is one side and 6 is the another side. So carboxylic group and amino group. So therefore the amido group is formed. So it is very amazing polymer. Nylon 6 double dot 6, and earlier in 1938 this was confirmed that nylons are synthesized in the laboratory first time. So you can see, imagine, since of the last so many, not only 1 century, uh, still 1938, and here 2038, still there is the long period. So it is the history is not uh, not going to 1 century ago. This one is only of whatever we can say around 83 years ago. So amazing, miracle, and this product is the nylon 6,6. So here we can continue polyamides, hexane dioic acid, 6 carbon dio, and the amine here, whatever we get, this one. So I'm whatever. One more thing is that nylon 6 is the 6 aminocaproic acid, and then condensation of 6 aminocaproic acid that configured the nylon 6. So here is the great picture of the whatever the here we can see the great picture of nylon 6. So nylon 6 itself, the 6 carbon atom, 1, 2, 3, 4, 5. So 6 carbon atom here, and after 6 carbon, the blue, whatever the blue itself is the amine and nitrogen. So nitrogen and hydrogen, we can say the trivalent nitrogen. So nitrogen, hydrogen, and red is the double bond oxygen. So carbon, double bond oxygen, and in the blue shade we have the nitrogen and hydrogen. So nitrogen combined with one of the carbon, and in case of the another carbon, so another carbon CH2, and one side this is the carbon double bond oxygen. So nitrogen is linked with CH2 group and carbon double bond oxygen. All of you are well known about the carbon double bond oxygen group is the carbonyl group. So here very specific nylon 6 is formed. So here the nylon 6 itself is obtained by the condensation, but here the self condensation. What is the self condensation? That is like a amino acid. So one amino acid combined with the another. So here the caprolactam, then we get the nylon 6. And in case of the nylon 6 double dot 6, here we can see that is the another way. 6 carbon atom, dicarboxylic acid, whatever I have discussed about here, hexamethylene diamine and hexane dioic acid. So carbon double bond oxygen, however the picture is the same, but difference itself is more is different. So this one is the product is the nylon 6,6. So there is a basic difference between the nylon 6 and nylon 6,6. That is, in case of the nylon 6, only 6 carbon atom, and they have the amide. In this case of nylon 6,6, first of all the 6 carbon double bond oxygen, then nitrogen and hydrogen, and then the 6th one. So here the major difference, whatever you can see in this particular case, the 4 the CH2, 4 CH2 in between the 2 carboxylic group, and here the 5 CH2 in between the 2 carboxylic group. Here 4 CH2, 1, 2, 3, 4 CH2, and then the carbon double bond oxygen. The red one indicates by the carbon double bond oxygen. So that is the major difference. And then after that, the NH group, then we have further the C6 of CH2. So that is the major difference between this, and that definitely gives a functional values. So functional properties are because of those particular specific functional group. So I think this is most important invention of the century here, because the nylons are directly related with the proteins. And proteins are the backbone of our cells, our muscles. So even here I can mention here, we can also prepare the bulletproof polymers, bulletproof nylons. So those bulletproof nylons are also the same way. However, there is the modification in the structure of the molecule. What is that? That is using the tertiary acid, and that is use of the dicarboxylic acid aromatic. So tertiary acid, the benzene, and then carboxylic group, and then this diamine, that is further the diamino benzene, and the process is the same. But what is the major difference? There are the aromatic compound, and in here we are using the. So in case of the nylon 6,6, here the six carbon atom, and there also the inside is the benzene, and that have the very great application in the security system. Whatever those, the ballistic, anti-ballistic polymers, great value. Even we can say the ancient technology that depends on the metals and alloys to protect our body, but with the bullets can be protected uh, by ourselves with wearing the cloth of the polyaramide. So polyaramide, whatever that is that discussed elsewhere. So here you can say that is the poly. So now we have this. Then nylon certain examples are also there, and here we can see the nylon 6 that 10, nylon 11, nylon 11 that is the self condensation. So nylon 6 and 10, so 6 part is there and then 10 part is then there. So hexamethylene diamine and then 10 of the dicarboxylic acid. So these are nylon, certain specific nylons are prepared. Now we can say this is the preparation of a very simple, and that is the nylon 6. Here the what we have, the thing nylon 6 is prepared from the eta caprolactam in the presence of water, which acts as a catalyst, and acetic acid as a molecular weight regulator. So nylon 6, this is one of the starting nylon. Here we can say that first of all, eta caprolactam, the cyclic compound where the carbon double bond oxygen and then NH group is there. So eta caprolactam in the presence of water, and water acts as a catalyst and acetic acid as a molecular weight regulator. So therefore, this typical combination of charge into the vessel and reacted under the nitrogen blanket at 250 degrees centigrade for 12 hours. Then we get the nylon 6. So here the polymer, and that is the polyamide of what we have. So this will be the polyamide of omega amino and caproic, whatever the hexanoic acid. So after this, there is the certain structural aspects. So here we can say the specific molecular weight, whatever earlier discussed in 1928, this was the very that high molecular weight polymers are that at that moment, because of the innovation, because of the so many ideas at that moment, the atomic structure was also completed. So the invention of neutron and the proton, so finally around that in 1931 the neutrons were also invented. So whole atomic structure was completed, except the chemical bonding was going on. So at that moment, the nylons were prepared. A specific type of nylon are frequently available in form of different molecular weight. The main difference between the such grade is the melt viscosity, and more viscous grade being more suitable for processing extrusion techniques. What is there is the certain technologies by which we get the nylon fibers. Extrusion means whatever the viscous, then we get the nylon sets. So nitrogen substitution here, whatever that can be here, carbon double bond oxygen nitrogen hydrogen group. So CS3 here will cause a reduction in the interchain attraction and a consequent decrease in the softening point. The softening point can be decreased is in the form of the elastic rubbery product. And here I have also discussed the copolymerization as usually to less crystalline and frequently amorphous material. So that material might be expected are through the leather-like, flexible. So leather, flexible, elasticity. That is because of the so many. So here the comparison between the nylon. So this is one of the question. and the question related with the nylon 6 and nylon 6. So here, what is the answer? More abrasion resistant, harder, having higher melting point, and so nylon 6 is the more harder. Why harder? Because I have earlier discussed in the case. Here we can see the structure of nylon 6 and nylon 6 double dot 6. So because of this structure, nylon 6 is the more harder than the nylon 6, even nylon 11. So that is also more harder, and with the help of the nylon 11, we can make the different machinery parts. Even I have discussed the ball bearing. So balls of nylon 11s are used in the ball bearing. Whatever the ball bearing in which certain oily, whatever the lubricants are used. So these are lubricant free ball bearing with the help of nylon 11. So nylon 6, the nylon 11. So both of the even this is the question. So the answer itself is the more harder. Abrasion resistant, whatever that both having high melting point, none of these. So this is so another question. The wrong statement here. We can compare. Polystyrene is a thermoplastic polymer. We want to give the protein is a natural polymer, that is I have discussed. Neoprene is the natural rubber, and polythene is a copolymer, while uh, and SBR is the homopolymer. So here we want to say which one is the wrong statement. Polystyrene, the protein natural polymer. Neoprene is the natural rubber. This is the wrong one. Why? In case of the neoprene, we have to discuss about, because in here we also mentioned that because of the certain um, additives, and we can get the leather like rubbery materials products are obtained by the nylon. So here the question neoprene is also one of the example of the uh, synthetic rubber. So synthetic rubber, that is the neoprene, and neoprene is the polymer of the chloroprene. So polychloroprene is the answer. And so polychloroprene, neoprene, so that is the artificial. Polythene is a copolymer. SBR, this is also the wrong one. Polythene is a polymer, addition polymer. Styrene butadiene rubber, that is the hetero copolymer of that. Here nylon 668, that is well known. What is the answer? Is the polyamide. Amides, I have discussed. What do you mean by the amides? That is the polymer. And, we can say amido group, amido, carboxylic group, and NH2 group. So nylon 6 is example of the polymer of amido group. So this is also the way polyamide. So correct answer is the whatever we have given. Thermoset resins, polyester. Polyester is another polymer type, and that is the combination of carboxylic group and with hydroxy group. Polyester group is formed, that is also the carboxylic acid derivative. Then none of these is not the answer. Nylon barely is here also. Scoring is the finishing operation due to the manufacture of fiber, which aims at improving the stretchability, whatever, that dyeing and coloring the detergent solution washing. This is the glycol soaking. So scoring is the finishing operation, and here the answer is the detergent solution washing. Now pick out the wrong statement here. Whatever you can give answer. Polymers made up of only one monomer is called the homopolymer. Polymers made up of only one polymer, that is the homomer. Polymers made up of more than one monomer is called the copolymer or the mixed polymer. Vulcanized rubber is more elastic than natural rubber. This is the wrong answer because when rubber undergo the process of vulcanization, and that is the process is that is the hardening of rubber. Whatever you can see the tire of the vehicle, and those tires are the hardening hard rubber, and those hard rubber obtained after the process of the vulcanization. So vulcanization is the process in which the rubber becomes the hard. Whereas in case of the natural rubber, that is the soft, all of you know about the well known, and that is the eraser. So eraser is the soft, and you can compare both eraser and the tire. So tire are very hard. So vulcanized are these are the it's more elastic. This is the wrong answer. The intermolecular forces in thermoplastic polymers are intermediate to that of the elastomer and fiber. Now, this is also you can pick out the wrong statement. Addition polymers are generally formed by chain growth polymerization. The condensation polymers are generally formed by step growth polymerization. Here, the Teflon is formed by step growth polymerization. This one is the bakelite is formed by the step growth. So these are the wrong answer is the Teflon. All of you know about the Teflon. That is also one of the thermoresisting polymer. That is, in case of the Teflon, that can resist up to 400 to 500 degrees centigrade. Bakelite is also one of the in 1935 bakelite was invented, and that is by the nylon. Now, here also the polymeric fibers are never produced by addition polymerization. Yeah, because condense polymer. So this is the wrong answer. What about the property of tracking the exhibited uncured rubber, the sharp melting point? So let's we can say, and finally we can give the answer to different questions. There are, I think, suppose various questions are there. The most important one, and that is the whatever we can say, and thanks to all of you. And I can summarize this for this. So whatever we can say here, I can revise that different questions. I suppose that can also give. So like concluding. So here the conclusion is that the polymers are of the specific materials, and however the polymers are already present in the nature, but those polymers are present in nature and different animals products, different plant product, whatever we are eating, the food ingredients, different types of foods having the certain polymers, and all of you are well known about the food ingredients. Those are the proteins, those are the carbohydrate, those are the fats. All those relates with the natural polymer. Even the skin, whatever the in case of the winter season, we are using the wool. So wool is also one of the example of polymer, and further we can say the silk. So silk is also one of the example of the polymer. And different types of polymers are available, whatever the skin, whatever the leather, and so those are the natural. But because of the great value addition in since the 1930 to 1950, the additions were the invention of the nylons in 1935, their existence, and in 1935 the invention of the bakelite. So bakelite also the polymer, and that is have the great value. So all are the miracles in our in the whatever the development of human facilities. So human facilities are provided by the certain polymers and specific polymers. Whatever we can say, the polyesters are also having the value additions in our different technologies, and the polymers, whatever the polythene, the simple one, packaging material, even the PVC, those polyethylene and PVC are explained in my different lectures. So you can see that particular presentation of polyethylene and polyvinyl chloride, as well as one thing, and that is the polystyrene, and those are the polypropylene you can also see. But those are also the great packaging material. But nylons have the great value addition, since the polyaramides are used as an anti-ballistic material. So polyaramide, those are the also the part of the similar uh, fashion, similar way of the nylon. The similar way, what was the similarity? That is the amide group. That is the polyamides. So even polypeptides are all of you are well known about the polypeptides. So since we can say number of the polymers have great application in our advanced technology. Even the nanostructures polymers are also available. Even certain polymers are also used for the treatment of our cell, and those are the drug delivery systems. So nanoparticles, so polymers are also useful for that. So little bit this nylons have the great value and great opportunity. If anyone have the query, then he or she can ask me, contact me, whatever my email ID and whatever my mobile number. So anyone can ask me what is the development, what I have discussed around the today's topic of the nylon. So all of you are welcome to any moment. If anyone have the, I think you can um, yeah, have the patience and listening. And most important thing is the to learn most value additions. So that is all about the nylon. Okay, all the best. Best wishes for your learning activities, best wishes for the listening, best wishes for the patience you have taken, and you can um, use this video for the knowledge sharing also, and like this video. That is all about. Okay, all the best. Best wishes.